Well, if a tsunami is headed your way on the Oregon or Washington coastline, you might not get the notification in time.
Explosive year for researchers at Oregon State University. They're predicting an undersea volcano.
Oregon coast shaken again, the Pacific stirs, and scientists hold their breath. The Pacific Ocean did not roar. It shuddered. At 3:17 local time, instruments along the western United States lit up almost simultaneously. Seismographs from Washington to Northern California recorded a sharp, rolling pulse rising from the deep, a magnitude 6 earthquake, striking off the Oregon coast, far beyond the visible horizon, where the ocean floor descends into darkness. The quake lasted only seconds. Its implications may last far longer. Residents along Oregon's rugged shoreline felt a subtle but unmistakable sway. Hanging objects trembled, windows whispered, far offshore. The seafloor cracked and slipped, releasing energy that had been building in silence beneath miles of cold Pacific water. For scientists, this was not just another offshore earthquake. This one arrived at a moment when the ocean was already under watch. An unsettled coastline. The epicenter lay west of Oregon, in a region shaped by some of the most powerful tectonic forces on Earth. Here, the Juan de Fuca plate grinds relentlessly beneath the North American plate, forming the infamous Cascadia subduction zone, a geological boundary capable of producing earthquakes far larger than today's shock. The quake was moderate by global standards, but its depth, location, and timing raised immediate concern. Within minutes, ocean buoys began transmitting irregular data. Not large waves, not yet, but unexpected motion. Small, fast-moving swells rolled across the surface, out of rhythm with the surrounding sea state. To the untrained eye, the ocean looked calm. To scientists, it looked uneasy. Strange waves, uncomfortable questions. Along parts of the Oregon coast, observers reported water behaving wrong. The shoreline breathed in and out more quickly than expected. Harbors saw sudden, short-lived surges. Nothing destructive, but nothing ordinary. Was it a coincidence, or the first whisper of something larger? Tsunami experts were quick to caution restraint. A magnitude 6 earthquake, by itself, rarely generates a damaging tsunami unless it causes significant vertical displacement of the seafloor. But science is rarely about single events. It is about chains of stress. And beneath the Pacific, one link in that chain is drawing intense scrutiny. Axial Seamount, the volcano no one can see. Hundreds of kilometers offshore, far beyond shipping lanes and satellite imagery, rises a vast mountain of basalt known as Axial Seamount. Invisible to the naked eye, impossible to ignore for geophysicists. Axial Seamount is one of the most active submarine volcanoes on the planet. It sits atop the Juan de Fuca Ridge, where tectonic plates pull apart and magma ascends from the mantle, quietly reshaping the ocean floor. Over the past years, sensors embedded in the seafloor have recorded something unsettling. The volcano's summit slowly inflating, seismic tremors increasing in frequency, magma pressure building beneath kilometers of rock and water. Axial does not explode like a Hollywood volcano. It oozes, it fractures, it reshapes the seafloor in silence. But history shows that when Axial erupts, it does so with earthquake swarms, rapid ground deformation, and sudden releases of energy that ripple across the deep Pacific. And now, a strong earthquake has shaken the region. Could these events be connected? This is the question echoing through research centers tonight. Earthquakes can alter stress fields across vast distances. A rupture in one part of the crust can subtly load or unload pressure elsewhere, sometimes enough to hasten volcanic activity. No scientist will say the quake caused anything, but many are watching closely. If axial seamount erupts, especially during a period of heightened tectonic stress, the consequences may not stay confined to the deep ocean. The tsunami question. Could a tsunami occur? The honest scientific answer is complex. Axial seamount lies more than 1,400 meters below the ocean surface. At that depth, even a major eruption would struggle to displace enough water to generate large coastal waves on its own. But tsunamis do not require explosions alone. They can be born from sudden submarine landslides, collapse of volcanic flanks, rapid fault movement that shifts the seafloor vertically. The Oregon margin is steep, sediments are thick, and earthquakes can loosen underwater slopes that have been stable for centuries. A large underwater landslide triggered by continued shaking or volcanic deformation could generate a localized tsunami, reaching the coast in minutes. Not guaranteed, not predicted, but possible. And in science, possibility demands vigilance. Cascadia, the shadow beneath everything. Lurking behind every discussion is the giant no one forgets, the Cascadia subduction zone. This fault has produced catastrophic earthquakes in the past, including the massive 1,700 megathrust event that sent tsunamis racing across the Pacific to Japan. Scientists stress that today's earthquake does not indicate an imminent Cascadia rupture. But every offshore quake is a reminder that the system is active. That stress is never static. That the Pacific Northwest sits above one of the most powerful tectonic engines on Earth. What scientists are doing now? Across the region, monitoring has intensified. Deep sea pressure sensors are tracking subtle changes in water movement. Seismic arrays are scanning for aftershocks and tremor swarms. Volcanologists are watching axial seamount for signs of rapid inflation or eruption. Tsunami centers are recalibrating models using fresh data from the quake. This is not panic. This is preparedness, because nature rarely announces its next move.